Suppose vector A, vector B and vector C be three vectors of length 1, 1 by 2 and 1 respectively, such that vector A cross vector C plus vector B equals 0. The acute angle between vector A and vector C is, so following are the options. Here we are asked to find the acute angle between the two vectors, that is vector A and vector C. So using this given equation, we have to derive it in such a way that we get the angle between these two vectors. So for that, first of all, let's write down this equation here, that is vector A cross vector C plus vector B, which is equal to 0. So we are familiar with this term. So this is in the form, that is A cross B cross C. We have studied it in the chapter vectors. So on further expanding this term, we get A dot C into B minus A dot B into C. So on writing this term in this form, we get A dot vector C into A minus A dot A into C plus vector B equal to 0. Here the value of vector A dot vector A will be 1, since the dot product of two equal vectors is 1. So on rewriting it, we get vector A dot vector C into A minus vector C equal to minus vector B, as I have taken this vector B to the right side. Here I am taking this negative sign to the left hand side, thus we get here positive and here it is negative. So on rewriting it, we can write it as vector B equal to vector C minus vector A dot vector C into A. Here we need to square both these terms in the left hand as well as right side of the equal to. So on squaring it, we get vector B whole square equal to vector C minus vector A dot vector C into A whole square. This is in the form A minus B whole square. So on expanding this, we get vector C whole square minus 2 into vector A into C. A and the remaining is vector A as well as C, so we can write it A dot C here, and the remaining, that is plus vector A dot vector C into A whole square. Now we need to substitute the values of vector A, vector B as well as vector C into this equation, as well as we need to write this A dot C in a form, that is AC cos theta, by avoiding this dot sign. So we get value of vector B is 1 by 2, 1 by 2 square is 1 by 4, and C is 1, so 1 square is 1, and the remaining is 2 into A dot C. Value of A dot C is AC cos theta. As the values of A and C is 1, we get A dot C as cos theta. So substituting that value, 2 into cos theta, as there is a square, so we are giving it to this, thus we get 2 cos square theta plus here A dot C value is cos theta, which we have already found. So cos theta into 1 is cos theta. So as there is a square, whole square, we can write it as cos square theta. From this, we need to add minus 2 cos square theta plus cos square theta, which we will get minus cos square theta. We have learned that 1 minus cos square theta is sin square theta, which is equal to 1 by 4. So, sin square theta is equal to 1 by 4, which implies sin theta will be equal to 1 by 2. As we have taken the square to the right side, we get root of 1 by 4, which is 1 by 2, and hence we will get theta value is equal to sin inverse of 1 by 2, which is 30 degree. So the correct answer is option B.
If you like this video, do subscribe and click the bell button.